Right, so this is the start of the P5 section for question 4. It's looking at motors. So the first part is asking us to give a name of a device that uses a motor and explain how it uses the motor. So we're after something that is powered by electricity that actually causes something to rotate in the main. So if we think of something like a fan, okay, the fan, it uses it to spin the blades of the fan so it can push air. So spin the blades of the fan. Now that is one option. There are loads of different options you could use for that. You could use a drill, so it could rotate and spin the drill bit. It could be a hairdryer, so it rotates the fan to push the hot air out. It could be a fan cooling system in a computer. It could be, and you had to make sure that if you were to do this one, it was an electrical car. And it's got to be an electrical car, and that is so it can move or even spin the wheels. Okay, now you had to make sure it was electrical car. If you didn't say electrical car, because the normal motor within a car is not the same as what we're looking at. What we're going to be looking at now is the actual motor effect. So it's just a dead simple fill in the missing gaps, and it is worth 2 marks. So this is the kind of question that you'd even have a guess at. Even if you haven't got a clue, you could just have a go. But the chances are, if you actually read through this in your head, and you can kind of fit in the one that makes the most sense. So if a wire carrying a flow of charge is placed at right angles to a magnetic field, it experiences a force, and that's exactly what causes the motor to actually spin. Okay, right, question 4C is we've got one battery, 2 identical motors and some connecting wires. So the first thing we need to remember is, first of all, the symbol for a battery, which would look like that. The symbol for a motor, which is just an M in a circle, and connecting wires, which are just straight lines. Okay, now he connects the components together in 2 different ways. Now, as soon as you're talking about circuits, the 2 main ways are series and parallel circuits. Now, these series and parallel circuits, the series circuits are, you can carry the loop around all the way. So if I draw the battery on, I can go through every component without taking my finger off the line and without having to take a different route. A parallel circuit is where you've got different branches coming off the circle in the circuit. So if you was to draw something like this, obviously you draw it a lot neater than I do. So this, now from the parallel circuit, the current has got a choice to whether to go over there or carry on going. So that would be get you the 2 marks for this particular question. What the next question is asking us to do is explain which one runs faster and why. Now, if you remember the experiments that we did with bulbs and adding the bulbs to circuits, if you add more bulbs to a series circuit, they go dimmer. Okay, if you add more bulbs to a parallel circuit, they stay at the same brightness. Now, this is all to do with the amount of voltage, which in turn leads to the amount of current and resistance and power that's flowing through the circuit. So if we take the parallel circuit and we took the voltage, say this was a 3-volt battery there, we'd have 3 volts going across it there and 3 volts going across this, this motor. If it was a 3-volt battery on this one, and we've put a voltmeter across there, we'd end up with 1.5 volts and 1.5